Great to see you here again. My name is Luc de Kuster, founder of the Kuster Academy. And in this video, I will talk about how we can measure the progress of the project using earned value management parameters. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at the principles of earned value management that will help us to create or to calculate the estimated end time of a project. Earned value management is a technique that's based on some simple formulas, and we are looking at the estimation of the parameters like time and cost at completion of a project. So earned value management provides us a simple way to do these calculations. Now, what we understand, what do we have when we start with earned value management or when we have a project? We have the cost baseline, and the cost baseline is basically the overview of the number of deliverables that we plan to create over time and the cost of it. So that's what we call the S-curve. And in our examples, we will simplify the S-curves or the S-curve by a straight line. Now, what we find in the S-curve is basically the value of the work that we plan to complete at a certain time during the project. Once we are working on the project, we will find the real parameter. How many deliverables did I create at a certain moment in time? And the value of those deliverables is what we call the earned value. In addition to that, we can measure how much we paid to create those deliverables, and we call that the actual cost. Now, when we are looking at schedule management, the actual cost does not come into play yet. The actual cost will be later used to calculate what is the estimated cost of the project at completion. Now, when we look at these parameters, we can define different parameters. We can define the schedule variance. The schedule variance, which gives us an idea how much do we deviate from the original schedule. We can also calculate an efficiency parameter, which is the schedule performance index. And finally, we can calculate the revised total duration or the RTD. Now, when we look at the graph, we see here the green line, which is, like I said, a simplified S-curve where we have a straight line. So we have a linear production of deliverables over time. And we find at a certain time, or the time T1, the end time of the project, we reach the budget at completion. And for construction reasons, I draw the line here, the planned value as a horizontal line, because from here on, all the value has been created. So we are not creating anything extra anymore. At the moment T in time, the time that we measure, we find the PV at that time. That's the amount of cost of the value of deliverables that I intend to create at that moment. I also have the earned value at that time. This is the value of the deliverables that we created on that time. And the third parameter, the actual cost in that period, is the actual amount that we paid to create those deliverables. So these are the basic parameters that we have, and we can already evaluate here. We can see what's the relevant position or relative position of EV to the PV. Here we see we created less value than we planned, so we're clearly behind schedule. And we also see that the cost to create that value is higher than we estimated, so we are over budget and behind schedule. The first thing to do is to define the schedule variance and the SPI. Now, the schedule variance is per definition the earned value minus the planned value. And we see when earned value is less than planned value, it will be a negative value. A negative value in this case, schedule variance smaller than 0, so we are behind schedule. We are not creating the deliverables as quickly as we estimated. Schedule variance equal to 0 means that we are on schedule, and a schedule variance larger than 0, we are ahead of schedule. Then we also have the schedule performance index, which is given as the proportion of EV and PV, so EV divided by PV, earned value divided by planned value, and we see an SPI smaller than 1 when we are behind schedule, an SPI equal to 1 when we are on schedule, and an SPI larger than 1 when we are ahead of schedule. So we can have this on the graph. We can see the schedule variance here, so which is clearly the difference between EV and PV. I cannot put the SPI here because we can not draw it here on the graph, but we can clearly see the schedule variance. The last element that we want to calculate is the revised total duration, and we know that the schedule performance index is given by the formula EV divided by PV, and we can determine the revised total duration, and we can prove that it is equal to RTD is duration divided by the SPI. It's easy to prove this. If we look at the following graph, I will explain you. Basically, the principle is that when we estimate that we will create value at the same rate as before, the project will be finished when all value has been created. It means when the earned value is equal to the budget at completion. Now, this is what we did here. So we have the RTD, duration divided by SPI, and I just extrapolate the way we have the earned value starting from the beginning until the line crosses the budget at completion, and that point gives us the new duration of the project, or the RTD. So that's what I wanted to share with you about the main earned value parameters that we need in schedule management. Anyway, that's it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next video. Bye bye.